Hi everyone, welcome back to this channel. In this video, I'm going to walk through a quick setup with you on the distance to fault measurements. As you can see on the screen, I have a FieldFox remote desktop and also a camera pointing at the FieldFox just to show you some of the setups that I have to go through before we get the final answer. So without wasting time, let's go straight to the hardware setup first. Let's walk through some of the stuff. So I'm using a FieldFox right now with a 3.5mm connector because it's a 9918B model. So I have an adapter here. You're going to see that in the DTF result later. So I have a BNC cable. So I can undo here and I'm going to show you how it looks like. So I have a BNC cable. So each cable is about 1.02 meter. So end to end, and I have two of these. Two cables here. I have a barrel connector in between because I want to show you how it looks like in the DTF format. So I'm going to join both cable right now. Just join it together to extend the length from 1 meter to 2 meter, and I'm going to connect this to the FieldFox. You might have heard this from the expert from Keysight to have a quick test on your measurements before you do calibrations, because back in the days when I get this unit, I will run a calibration straight away. That is not the best sequence because we might need to change some of the parameters like power, number of points, frequency, things like that. And if you change any of that after the calibrations, we need to recal again. So the best thing is that you verify the measurements that you want and make sure that that's what you want in terms of all the setup. Like I have bandwidth, number of points, start frequency, power level, things like that. Then only you remove the cable, then you run the calibrations, then you do a final measurements. So I really start from scratch, and let's go to preset factory, mode, CAT, which is cable antenna test. So I don't really have GPS, it doesn't really matter, and I will go straight to measure, distance to fault. So because this cable both add up together is about 2 meters in terms of physical length, so I'll set the start stop into something shorter than 100 meters. Let's go to frequency. So stop distance, because it's 2 meters, we can add in some buffer because we want to see where's the open end. So I'll stop at about 5 meters. It's up to you, you can play around with that. So you can see that this is the first connector, which is here, somewhere this. And then we move to here, which is the middle barrel. And the last one is the open side here. And you might ask, what is this? This is actually the mirror from there. We tend to ignore that. How do I know this is the open part? Don't quote me on this. This is a very bad way of testing, but we just play with what we have. So if I put it there, you can see that the highest point is actually dipped by a bit. If you do a quick marker pick, it's about 3 meters, so within that acceptable range from 2 meters. Right, how do I know this point is the center, the barrel? I can actually unplug this right now. As you can see, you see that the center point actually go up further. So it shows that there's a discontinuity here, which is the open side. So let's put it back here. So from here, I'll do some of the setup like the bandpass filter or low pass filter, because I want to change the resolution, things like that. You can actually play with it. Just go to frequency, setting. You can just do all the setup at one go, then you see what's going on at the end of the setup. So let's go through briefly. So low pass is when you have just a cable. This is the best options to choose, but you can actually change that to band pass. So band pass is needed when you have a filter in between the cable. So when you have a network of cable, filter cable, and you do not want to disconnect the filter because it's up in the base station, you can actually use band pass. So it will specifically set the start-stop frequency of that response, and from there FieldFox will calculate out based on the wavelength and the response time. So by changing this, you will see that the resolution sometimes will change from the default value to something different. So let's do that. Let's give it a try. Let's say we set 100 meg minimum to 500 meg. So let's say that's my filter. So you can see the resolution is very bad. So I do recommend for a cable, just go with the low pass, and FieldFox will calculate it based on the best setup. And this is where we can set the velocity factor if you want to. Right now we can set that, but that's another way of doing it. I'm going to show you later. And resolution, this way you can change the number of points. For example, I can change it to 1. So the higher the resolution, the slower the sweep. But if you're out in the field, it's not much of concern, then you can change that. So once we've done that, just escape. So you can see that there's more points across the measurements. So let's say this is what I want, and I'm happy with the output power. You can change output power here. Sweep, sorry. So you can go to measurement setup, power. So this is manual -15. You can set as according to your need. If the cable is much longer, set a higher power. If the cable is shorter, you can lower down the power. Alright, so we just leave it as it is. So let's say this is what I've expected in the test. The next thing I want to do is to run a 1-port count. So before running the 1-port count, let's assume that this connector is part of the system. I want to count until the beginning of this port. So this is part of the system, and I'll remove this cable because I want this cable to be the device under test. So I remove that. Let's go to count and response count. So response count is the quick and easiest way. It's not the most accurate, but it does give you some idea of how it works. So if you have a mechanical count, then by all means go with that. But if you are out in the field and forgot to bring the count kit, and you only have a response count, I will go with that. So we have open response and short response, and this for port 2. So currently the connector is open port, so I'll go with open response and measure. You see some slight difference in terms of before and after count. I'm going to show you how you can see that. So let's connect back the cable. So let's put the marker to the highest peak, which is the open portion, which is not here. Let's go to here, somewhere about 3.15. Yeah. Right, 3.06. So this is after count. Let's remove the count. Let's see. Before we count, what was that answer? So this is how you turn off the user count. So once you're done, escape. So you can see that when it's count, it's 3.06. When it's not count, it's about 3.13. So it's about 7 cm improvement. So the next thing to do, because we know that the physical length of this combined cable is roughly about 2.04, and then plus a barrel about 2 centimeters, 2.06 meter. And this is open side, it doesn't show 2.06, it shows a 2.13. The reason being is that the velocity factor is at 1, which is 100% of speed of light, which is wrong because in the cable, in the copper medium, speed of the waveform is actually slower than the speed of light. Where do we change that? So we can go to measurement setup, cancel, measurement setup. So 2 ways. One is you change it manually. For example, I know this cable roughly is about 68% of speed of light. So we enter it, and we do the measurements, let's marker, let's go back here. So it's roughly there, 2.13. Okay, this is what we normally do. The reason why I'm putting a barrel here is just to show you that is discontinuity here. So the next thing I want to show you how to get the velocity factor is that if you know the cable property, for example, you get RG58 from a third party to build this type of BNC cable. So you can actually go to measure, setup, DTF cable specification, edit recall cable. So you can edit a cable, you can build a new cable property, then you can save the cable or you can record the cable. So we're going straight with record cable. So we have a long list of cables that's available in the market, and you can actually record to the type of cable that you are using. Let's try RG58. See, so we record file, and it will show you that the velocity factor is 0.667. So let's try this, see whether it's 0.667, it's 0.68. So this is more likely. The type of cable that is being used here most likely is the RG58C type. So the question comes, how do I edit that? So one way of doing it is go back to measurement setup, DTF. I will do this, edit cable. I will change the name. I'll change the velocity factor. I will change the cable loss if I have the information. And then once I've done, I click done. And I will save this cable as something that I want to add on to the database. So just type in whatever you think and then click done. So for my case, I just put it as cancel. So if you worry that you accidentally changed the default cable, the best is FTP into FieldFox, grab the whole database or cable into your computer as a backup, and then you can overwrite it anytime you feel that someone has messed up with your database. The other one is to approach Keysight folks, and they should be able to zip it up and pass it to you. So I hope this helped. This is just a very quick DTF measurements on a cable. Thanks for watching.